Hey there, science enthusiasts and curious minds. Buckle up, because we're about to embark on a mind-bending journey through the fabric of reality itself. Did you know that time isn't the rigid, constant force we experience in our day-to-day lives? In fact, scientists have proven that time can actually slow down, speed up, and even twist itself into knots. This phenomenon is called time dilation, and it happens when you move close to the speed of light, or when you're near massive objects with intense gravitational fields. Mind-blowing, right? But hold on to your hats because we're just getting started. Today, we're diving deep into the cosmic rabbit hole of bending space and time. This isn't just the stuff of sci-fi fantasies or wild imagination. It's rooted in real, cutting-edge science that has captivated our imaginations in movies, books, and the forefront of physics research. So, get ready to have your perception of reality turned inside out, because I'm going to show you some tricks and examples that will illustrate how these mind-bending ideas actually work in our universe. Now let's address something that trips up even the brightest minds, the common misconceptions about space and time. Many of us think of time as a straight, unwavering arrow, marching forward at a constant pace. But in reality, it's far more complex and malleable than we could ever imagine. For instance, you might have heard that if you were able to travel close to the speed of light, you could actually time travel into the future. Sounds like a plot from a blockbuster movie, right? Well, here's the kicker. It's actually true. This is called the twin paradox, where one twin goes on a near light-speed journey and returns to find their earthbound sibling has aged much more. But that's just the tip of the iceberg when it comes to the weirdness of space-time. Understanding why these phenomena are possible requires us to completely rewire how we perceive time and space. It can get really mind-bending because our everyday experiences don't reflect the bizarre realities of physics at extreme scales. So, let's unravel this cosmic knot together. All right, let's dive into the nitty-gritty of the science. The bending of space and time comes from Einstein's theory of relativity, which tells us that massive objects like planets, stars, and black holes warp the fabric of space-time around them. Imagine a trampoline with a heavy bowling ball in the center. It dips in the middle, right? That's how gravity works in space. But it gets even weirder. Near a black hole, space-time gets so twisted that even light can't escape. Time itself slows down dramatically near these cosmic monsters. If you were to watch a clock falling into a black hole, you'd see it tick slower and slower until it appears to freeze at the event horizon. Here's another mind-bender, the concept of gravitational lensing. Massive objects can bend light so much that they act like giant cosmic magnifying glasses. Astronomers use this phenomenon to observe distant galaxies that would otherwise be invisible to us. Now here's the fun part. I'm going to show you a simple trick to visualize these concepts. By using a few everyday objects, we can mimic how space and time can bend, stretch, and warp. Stick around because this is going to blow your mind. Okay, here's the moment you've been waiting for. Grab a sheet of stretchy fabric or a large piece of spandex if you have it. Now, take a few small balls. These can be marbles, ping pong balls, or any round objects of different sizes. Place your fabric on a flat surface and pull it tight. This represents the fabric of space-time. Now gently place your largest ball in the center. Watch how the fabric sags around the ball, creating a deep well. This dip represents how a massive object, like a star or black hole, warps space-time. Here's where it gets cool. Take one of your smaller balls and roll it around the edge of the fabric. See how it orbits the central object? That's exactly how planets orbit stars. They're actually following the curvature of space-time. But wait, there's more. Try placing two large balls close to each other on the fabric. See how they create a complex landscape of dips and curves? This is similar to how binary star systems or galaxy clusters interact gravitationally. Now for the grand finale, time dilation. Imagine tiny clocks on each of your balls. The clock on the ball deepest in the well, closest to the massive object, would tick slower than the ones higher up or on the flat part of the fabric. This simple trick visually shows how space and time are interconnected and can bend and stretch in ways we can barely comprehend. Pretty mind-blowing, right? So to recap, we've explored the fascinating concept of bending space and time, starting with the mind-boggling idea of time dilation. We've moved through common misconceptions, delved into the weirdness of black holes and gravitational lensing, and finally demonstrated how these principles can be illustrated with a simple yet powerful visual trick. We've seen how massive objects can warp the fabric of space-time, how this warping affects the motion of other objects, and even how it can slow down time itself. It really shows us that the universe is far more complex, interconnected, and downright bizarre than we could ever imagine from our everyday experiences. Now I want to hear from you. What did you think of our space-time bending demonstration? Did it help you visualize these complex concepts? Maybe you have questions about other cosmic phenomena you'd like explained. Drop your thoughts, questions, and mind-blown reactions in the comments below. And if you're hungry for more mind-bending science, check out my other videos where we explore even more awesome scientific concepts, from quantum entanglement to the possibilities of parallel universes. Don't forget to like and subscribe for more cosmic content that will challenge your perception of reality. Thanks for joining me on this journey through the fabric of space-time. Remember, in a universe this strange and wonderful, the only limit is our imagination. Until next time, keep looking up and questioning everything.